Welcome to Study Loop.
Okay, it looks like you've got the right idea answering this question. However, you're only supposed to identify a single polar covalent bond, not all of them. And so I think that's where you went wrong. But nevertheless, let me sketch out structures here. Right. It wants you to identify a single polar covalent bond. In fact, carbon-hydrogen bonds are not classified as polar covalent, they're purely covalent, right? And this is purely due to the electronegativity difference between the atoms. Carbon and oxygen are very different in terms of electronegativity. Carbon and hydrogen are essentially the same, which is why they form covalent bonds. Carbon and oxygen are so different as to form polar covalent bonds. So you would say yes, like you did, the carbon is positively charged, and like you did, the oxygen is negatively charged, but you would not put anything in the box for hydrogen or the other hydrogen, right? Because these are not polar covalent bonds. Likewise, when we're looking at the cyano group, right? We've got a box above nitrogen, a box above carbon, a box above hydrogen. You don't want to put anything in the box above hydrogen because carbon-hydrogen does not form a polar covalent bond. You do have the right idea, though. Nitrogen is partially negative, while carbon is partially positive. Okay, and finally we have our phosphorus, chlorine, hydrogen, and hydrogen. Again, phosphorus and hydrogen have very similar electronegativities, and so we would not count these as polar covalent. We would simply call them covalent and not put anything in the boxes. Whereas between phosphorus and chloride, as you have correctly identified, phosphorus is partially positive and chlorine is partially negative.